Hi.
Hey, how are you doing?
Good. Not bad. How are you?
Okay, cool.
Okay. So I went through the two examples that I sent you.
Yeah.
Um, right. So it makes sense. I guess it makes sense, but I'm scared that if another example comes up, I won't be able to do it.
Yeah, here. Hold on one sec. It just froze on me. Wait. Here, let me open it again. Okay, so I wanted to say a couple of things. So there's only four forces in the universe,
Okay.
and mostly only have to know about two of them. So, there's the gravitational force, the electrostatic force. There's a weak force, which is responsible for radioactive decay, but you don't need to know anything specific about it. And then there's a strong force, which is what holds, a nucleus together, which you don't really have to know about. So things like normal force and frictional force and those types of things, those are just they're not actual forces. They're not action at a distance forces. They're just like contact forces, which aren't really forces. It's best to think of everything just through the actual like fundamental forces that are present in the universe. So what I wrote in the notebook, so I wrote the force due to gravity and the electrostatic force, and you see how and this is between point sources.
Mm-hmm.
So you see the similarity in the two equations, right?
Yep.
And then I kind of wrote between point masses and charges, and then for 1 point mass or charge, everything comes down onto that like sphere. And if you zoom in on that, at like infinitely, that the curve of the sphere becomes flat.
Mm-hmm.
So it's as if you're on Earth. So that's where you get that uniform field. So that's how, like on Earth, like if you take, for the when you use the universal law of gravitation, right? If
Mm-hmm.
you plug in the mass of the Earth and the radius of the Earth, you get, and that universal gravitational constant, you get little g. And same thing goes for the electrostatic force. You just get, capital E, which is basically the electric field.
Mm-hmm.
Now, so this is like a connection that they don't really like tell you about in MCAT level physics, but it's a very very like important thing to think about, because when we think about little g, we only think about acceleration.
Mm-hmm.
And when we think about electric field, we think about an electric field, but that acceleration, little g, is the same thing as a gravitational field. So that's where I wrote about Newton's second law, F is equal to ma.
Mm-hmm.
So, you know, get really good with units
Mm-hmm. Yeah.
and being able to see things like that, because,
Yeah.
a Newton is, kilograms times, meters per second squared, right?
Yep.
So that's what we're used to seeing, but if you rearrange that, you can also get newtons per kilogram.
Mm-hmm. Yeah.
So instead of thinking of it as just an acceleration, think of it as, if you're in a gravitational field, it requires this many newtons to move something that's 1 kilogram, like in that gravitational field. Okay?
Mm-hmm.
So I wrote the only difference between gravity and electrostatics is, one's between masses and is always attractive. The other one is between charges. So, so that's where, and then I talk about how acceleration can be misleading. So Now on to the questions. So these questions, like one is like whatever, like a pulley, tension, rope stuff, and the other is that as well, but with an inclined plane.
Mm-hmm.
So don't think about it as like, you know, the like there's no other forces to think about here besides that of gravity. Um, so that's where I just use Newton's second law.
Right.
And Newton's second law, like, it's not just F is equal to ma. Like, I wrote that, like, capital sigma that looks, what I mean? Looks like an E.
Mm-hmm.
That means, like, the summation, like, the sum of all the forces.
Yeah.
So the net force, right? So for that first question, right, all I see is that, like, don't even, like, they try to complicate things by making, like, tension on, like, force, or the tension that a rope is experiencing. But you just cut the middleman out and just think about it in terms of, like, if this was in front of you, right? And, clearly one mass weighs more, like the capital M, right? So that's going to go down. And then the little m mass is going to go up. And we just need to figure out, like, the acceleration of it.
Right. So does that mean so the heavier mass is gonna go down and the lighter one's gonna go up, right? So is the acceleration the same for both? Like the acceleration that the mass goes down is the same as the acceleration of the mass goes up?
Yes, the net acceleration, correct, yeah.
Okay.
Yeah, so because they're tied together, so yeah.
Right.
So if you want to be technical, right? One is going to be negative because the smaller mass is going up,
Right.
and the one on the right is going down. So, if you want to be technical, but you know, it whether it's positive or negative is just a matter of direction. So you don't
Yeah.
have to be that technical about it.
Okay.
As long as you know that aspect of it. So when I first asked you the answer for the second one,
Mm-hmm.
it was that's where I didn't realize that they were going in the same direction, so I subtracted it first.
Yeah.
And then I was like, oh, they're going in the same direction, so I added it. So you're gonna see in
Wait,
these two examples.
adding
Hmm?
so you're saying adding in the acceleration?
Oh, okay. So here, I'll go. Like step by step. So, so that first one, right? So first thing I draw, is basically like whatever force, uh, diagram, force
Yeah.
vector diagram. Wait, force free body diagram.
Your body.
Yeah. So there's the in green like little mg, and then in green capital like mg, right? And they're going in opposite directions, right?
Mm-hmm.
Um, so so I write, F net is equal to, so you just add the vectors.
Mm-hmm.
So, capital MG plus negative MG, which is just basically capital MG minus MG.
Mm-hmm.
And we set that equal to, like, for Newton's second law, like, we want it to be equal to, like, MA. And in this case, since it's a combined system, m is the sum of the two masses,
Oh.
right?
Mm-hmm. Yeah.
Yeah, because we're trying to find the net force, which involves the net mass and the net acceleration, right? So that's I also wrote, like, down in red, like, use variables until you can't, because if you go too quickly into plugging things in, like, you might like whatever, you can do whatever you're comfortable with, but you'll see in the next example how like it's better to not do that. So like for instance, I wrote like capital MG minus MG, and I factored out the G, and then I
Mm-hmm.
divided the the sum on both sides, and then I plugged in the numbers, right?
Yeah.
So I just get 1/3 of G, right? And G is 10, so just 3.3, right?
Yeah.
Okay. Now, for the next one, it's the same kind of thing, right? There's an inclined plane involved, and they're going in the same direction, so we add them.
Mm-hmm.
So, so for inclined planes, like, you know, I don't like to say just memorize things, but for an inclined plane, essentially, like, as it goes along the inclined plane, it's mg sine of theta.
And then perpendicular is cosine,
Yeah, exactly.
which
You should.
memorize for the exam.
Yeah, yeah, and you should also. Oh, I should also send you like a list of like math things to memorize, like sine of theta, like for instance. Um,
0 to 90. Yes.
Wait, what's that? Oh, oh, okay. So 0 to 90, and then cosine, it's the reverse.
Yeah.
Okay. So all right. So basically, I wrote mg minus mg, like little mg, right? Sine of theta is equal to the same thing, and
Yeah.
so this is where working with the variables works, like helps because they cancel, right?
Mm-hmm.
And so you're just left with g times sine of theta, which is 1/2 times g, which is 5.
Mm-hmm. Yeah.
So, okay, so I guess you're saying you're worried, like, what if you see it again?
Yeah. Well, it's just okay. So on my exam, I had a question that was very similar to the second one. I
Yeah.
had a passage on it. It was
Yes.
not a ramp, but like on a ledge. So like very similar.
All
And
right,
I just
but
had
you wouldn't use any trigonometry, like no sine cosine stuff then.
yeah. But I just
Okay.
like I guess all well, some of the questions weren't physics, but like the physics questions I just totally guessed.
Yeah,
I
yeah.
had no idea. But yeah,
Um,
I just didn't know like F net is equal to MA, or like I
yeah,
didn't know what F
they
net is.
yeah they simplify it to is equal to ma, and that's I'm a stickler for physics. Like it's precise for a reason, and that's why it's not just F is equal to ma. It's the sum of all the forces, aka the net force,
Yeah.
that produces that overall. Because that's what's Newton's second law.
Mm-hmm.
So so that's why for this, like, since because we're treating this as a system, right? If we were to just if they asked you, like, in this whatever pulley question, right, what's the acceleration of the like the smaller box or whatever, then you would only really, like, that would be a different thing, like if the larger box wasn't there, I'm saying.
Okay.
But since we're treating it like a system, that's where it becomes different.
Mm-hmm.
Um, so okay, so let's see, what other types of questions you have. So you have the blueprint thing, which is really good. There's a lot of really good questions there. I think I can
Um,
still have access to it. Let me see.
no, I didn't send it to you, but so I was thinking, so I just did some UWorld questions that were like purely like force related, and
Yeah.
I had some questions.
Oh,
So
okay.
maybe we can go over that.
Sure.
Yeah.
But I just letting you know, I still have access to my blueprint account, so we can use that as well.
Yeah,
Um,
it's just for blueprint, I haven't like figured out which questions
yeah.
to like go over yet. So
Yeah. Okay, so let's see. You can share
Share
your
screen.
screen. Yeah.
Yeah. Okay. All right. So I did 20 questions and I guessed many of them.
Okay.
So
All
there you
right. So
go.
80 kilograms is suspended by his arms on Earth. Tension of
Yeah.
lumbar disc 1. Acceleration due to gravity is this. Okay. So first of all, um, we're going to know that this guy weighs 800 newtons, right?
E yes. Yes.
Okay. So, just making sure. So, they're asking what's the approximate tension on just lumbar disc 1, right?
Yeah. Mm-hmm.
So, so I just want you to start to get like a thing I call number sense. If the
Mm-hmm.
dude weighs 800 newtons, 700 newtons is an awful lot to place on a disc, like a vertical disc. Wouldn't you say?
Yes, but 400 is also a lot. So,
400 is half of his weight.
yeah. But
And
then at the same, well, I don't know. I didn't really think of it that way because I feel like if the force is coming down on the spine, then the spine is also coming up
well,
with
he's
force.
suspended by his arms, right?
Right.
So yeah. So imagine that, right? And
Right.
lumbar is lower back, right?
Right. Right.
So if you're suspended by your arms like this, right?
Mm-hmm.
A lot of mass is above the lumbar region, right?
Mm-hmm. Yeah.
Like almost half, right?
Right.
So right away, I would say that 700 is way too high.
Okay.
Um, so that's just like a number sense kind of thing. Um, so okay, so we're trying to look for what lumbar disc 1, right?
Yeah.
And just from the, I guess, location of it, right?
Mm-hmm.
So the location of it essentially just means that. Oh wait, what are you showing? Oh, okay.
Oh, no.
Oh,
Nothing.
okay. So uh so yeah, so okay. So this is a guy that's basically just, being like held up by his arms, right?
Mm-hmm.
Um and like, you know, basically like, all right, so I don't want to say just because it's halfway there. Um, that's what, like, I would instinctively choose, but let's see if I can answer it based on so I guess I would look at, let's see, blah blah blah.
So I just didn't know how to calculate tension. That's basically where I was very stuck on.
Tension is just force.
But like what kind of force?
Uh, just like not a real force. If you want the real force, it's like the molecules. It if you want the real force, right? It's gravity pulling against the molecules, the electrostatic force of the atoms of the thing that the guy's spine is made out of. But don't think of it like as anything else. Just think about it as like literally um like weight.
Okay.
Like if the guy is suspended by his arms on Earth, like, and
Mm-hmm.
you put like a scale or whatever on his like lumbar L1 or whatever,
Yeah.
like how much would that weigh, right?
Right.
So
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 yeah,
basically, yeah.
the explanation is literally just because the lumbar is
That's
the
what I was
middle.
gonna say.
That's
Cause
literally what
it's
this says.
just it's just halfway there, yeah.
So why is it that if it's halfway, then you just divide by two? That's what I don't understand.
Because listen, so let's say, do you have like a little like brother or sister or baby or anything like that? Okay. Um hmm. So let's see. Oh, what about doing like a pull up?
Yes.
Okay. So when you're doing a pull up, right? Or not even a pull up, when you're hanging,
Hmm.
right? Um,
Yeah.
since you're like hanging, like you're like so so let's say that you're not doing a pull up and you stand on a scale and you get your weight, right? And then let's say
Hmm.
you're hanging like from like, a pull up bar and someone puts the scale under you.
Right.
Do
It's
you
gonna be light.
what's that?
No, I just said it's going to be lighter than what you
Yes.
act.
Yeah, it's going to be lighter. Now, how light is it going to be? It depends on how like the positioning, right?
Hmm.
Like if it's going to be basically someplace that is like higher, right? Or someplace
Hmm.
that's lower, it's going to be a different weight essentially. But basically, like the way that I looked at it is 700 newtons. So like first I looked at 80 kilograms. Whenever you see that, just multiply by 10 and be like, that's the dude's weight,
Hmm.
newtons, right? And so I
Yeah.
see something that is 1/20th of that, which is 40 newtons, right? I
Yeah.
see something that's like 70 newtons. Then I see something that's one half. And I see something that's very close to the guy's actual weight. So if you're hanging like, from like your pull-up bar, right? How
Hmm.
much, you know, like first of all, it's the fact that you're hanging, right, means
Hmm.
that you're going against gravity. So you know, you're literally not weighing as much, right?
Yeah.
And just it's basically, I guess the tricky part about this is it asks specifically lumbar disc 1.
Yeah. Right. Yeah.
So um so I so okay, I mean, tell me how you looked at this, cuz the way I looked at this was just I knew it was half because I know that lumbar disc 1, the lumbar portion is the lower part of your back. So you have your legs. And that's pretty much
Right.
half of your body.
I guess I just don't see how the length of the body is like related to the tension. Like I'm not sure where the relationship is.
Okay, okay. So let me think of
Is it? Yeah, I don't see how it's related. All right.
okay, okay. So let's say that you do let's see. I don't want to say like Jesus, but cuz okay, okay. Wait, so all right, you said you don't see the connection between which specific aspects?
Tension and like the fact that lumbar is at the happy body. Like why is it
Mhm.
that tension is related to where it is on your body?
Yeah, yeah. So, okay, so this would not matter if the guy was not suspended by his arms,
Yeah.
because then the gravity is bringing your entire weight down, right?
Hmm.
Now, how about this? Imagine like you like bow or something. Like you go like complete like from this like standing position to this,
Mhm.
right? Like if you were to draw like a free body diagram, like here your free body diagram would just be mg going straight down. Here it would be mg going straight down like here and there.
Mhm.
All right? Now, you're not gaining any weight just from doing this change in position. But since there's two like force vectors now, they're going to be cut in half to
Okay.
add up to that same thing.
Okay.
So and so it dep- so like let's say that this person was
Okay. No,
yeah.
I think I kind of see that. So I think what I'm seeing right now is like, you know how if it's like a traditional pulley, so you have like just like a circle and like a string around it,
Yeah.
because if you're going around this thing twice, that's why it's more efficient and like requires less force because
Um
bending it kind of.
I mean kind of I wouldn't like be too I wouldn't like I know like you're trying to figure out like tension and you're seeing that in a context before you saw that in the context of like a pulley
Yeah.
or like a rope
Yeah.
um but just see it as a weight.
Okay.
Okay, so
Okay. Right.
you
Okay.
know so
All right.
and people have different like center of gravity and things like that. um you know like whiplash.
Sure.
Like so like if you get into a car accident
Okay.
and you like crash, so the inertia like whips your neck forward and then back,
Mm-hmm.
so all of that tension is in your like cervical spine,
Mm-hmm.
and that tension, is it going to be that of your entire weight
No.
or is it going to be that of like your head?
Okay. Just probably just.
Yeah, yeah.
Okay.
So yeah, so hopefully that, um, yeah, hopefully that made sense. Did the
Yeah. Makes
responses say anything else besides that? Let's see.
the
The weight thing, okay. Tension, like I don't like using T for tension. I think it's just better to just put force. Um, but yeah, I would say the midpoint thing
right.
basically.
Yeah. All right. Let's go to some other questions.
Okay.
Okay, this one's fine. 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 Okay. I mean, so this passage, let me just have a look. Okay. This passage, I guess it's just this question that I just don't get it.
Okay,
I'm
for
not sure
equally
what they're trying.
sized trocar cannula systems, whatever that is, incisions made for blunt tipped trocars are smaller than those made by sharp tipped trocars. Alright,
Mm,
that makes sense. Like, right?
yeah.
Forcing the skin to uh, stretch more around the cannula. This option. Sorry, one sec. Okay, so let's see. Sorry. Okay. So yeah, the thing that's sharper is going to make, a small incision. The thing that is not as sharp is going to cause it to like tear more, right? Instead of just cut.
Wait, it says the incision of the blunt tip is smaller than the sharp one.
Oh wait. Okay, let's see. Sharp tip, blunt tip. Okay, equally SARS. Okay, forcing the skin to stretch more around the cannula. Oh, okay. I see. Um. Okay. This option better um prevent slipping after the cannula is inserted because
So
yeah.
I chose D because I was like, okay, if it doesn't slip, then it probably has better or larger friction. So I just chose it. And I didn't know how it was connected to like normal force at all.
Oh
So
yeah. So okay, so I know. All right, so the same thing with normal force and frictional force and all that stuff. Those aren't real forces. They're applications of the normal force, which is an application of the gravitational force, but not real forces. Um. So okay, now so let's see. Trocar, cannula, incision for if it's a blunt tip is smaller, forcing the skin to stretch more around it. Prevent slipping. Okay, so we're dealing with slipping, right?
mm-hmm.
So what should you think about with that?
Slipping.
Yeah.
Well, my first instinct is friction.
Good. Here, I'll be right back. I have to open the door for someone. Hey. Yeah, no problem. Sorry, I had to let someone in. Okay, yeah, good. Friction is what you should be thinking about. Okay, now, if it prevents slipping, it shouldn't decrease the friction.
Yeah, exactly.
Let's see. So all of these things are still about friction, right? But do you see how? All right, so you see how like friction is a function of the normal force?
Yeah, I just remember there's like some sort of formula that relates the two, but I don't remember it
So
exactly.
think about it this way: like you have like a rug, and there's like a box that you need to push across the rug, right?
Mm-hmm.
Now imagine, so imagine like, let's see if I could use something, um, like okay, so like this across like this, right?
Mm-hmm.
So like, all right, this is neutral, just me pushing it like this. All right, now imagine if I pushed it like at this angle.
Mm-hmm.
Is it going to be like harder for me to get this to slide? Okay.
Yeah,
Now, why do you think?
because of the angle.
Okay, what about the angle?
Because I think it's related to like work and how like if you want to maximize the amount of work done, then you want it to be like well, it's like because the work equation goes something like FD cosine theta. So you want it to be you want the cosine theta to be like 1.
Well, tell me what normal force is.
Normal force is I have no idea,
So,
honestly.
when you step on a scale, um, gravity pulls you down towards the center of the earth,
Right.
Electrostatic force of the electrons in the atoms of the scale and all that other stuff prevent you from going to the center of the earth. So what the scale actually measures is and that's what we call normal force. Now, this can change. Like if you're in like an elevator, right? And you step into an elevator and you go to like floor 5, right?
Mhm.
Initially you feel a little heavier, right? Because of the acceleration.
Yeah.
If you were to step on a scale in an in an elevator and you do that for that brief moment from going from, a stationary elevator to accelerating upwards, on the scale your weight would read something that's higher, that's heavier.
Mm-hmm.
Because we're putting a greater acceleration against it, which increases your normal force. And the opposite is true, is if the elevator is going downwards. Because when you go down in an elevator, you feel weightless for a second.
Right.
And if you were to step on a scale, your weight would go down a little bit.
Mm-hmm.
So normal force is just like material responding to the gravitational force.
Okay. Is it always perpendicular to the gravity force?
No, because okay, yeah. You can see applications of it, like for instance, something on an inclined plane, right? And if that inclined plane has friction, has friction, then normal force is different, right? It's like mg whatever cosine theta. And but yeah, it's yes, it'll be like it'll be perpendicular.
Okay. So so in this case, if you increase the normal force,
Oh yeah, so when when you move something, right? So like this is like completely parallel, right?
yeah,
So normal force is constant. This, right? Like part of it is going this way, but the other part's going down, right?
yeah,
So this is going to do what to the normal force?
like decrease it.
Decrease it, or if I'm like pushing like against it?
Oh, uh, increase it.
Yeah. Which means that it's going to be pressed up against this surface, making the friction stronger.
Okay.
Now, the opposite is if you like had something like attached to this that you pulled at, that angle, like this same angle, but imagine I'm pulling it.
Yeah.
That means that pulling it like above, the ground a little bit, so its normal force decreases, so its friction's going to decrease.
Right.
Okay, so that's just to make an intuitive connection between normal force and friction, okay?
Okay. All right. No, it makes sense though.
Yeah. So okay. Now now if we know that the answer is going to be something about friction. Now we just need to know what like components of the frictional force are involved. Okay? So so tell me what the okay, so so tell me what the coefficient of friction is.
Coefficient of friction, it's a it's kind of like a property of the material, And
Yes.
it's like a number that tells you if something is very slippery or not.
Yeah, it's essentially just something that's specific to whatever that material is.
Right.
So it only depends on the material. So
Yeah.
between these things, it's the same. It's what, skin, same
Yeah.
material, same coefficient of whatever, static friction. So that's not going to change.
Right.
But you're on the right track in terms of knowing that there's going to be more friction.
Mm-hmm.
So all right. So you could go about this in both ways. Like first of all, you can be like, okay, I know that friction's going to increase,
Mm-hmm.
so you can cross out B.
Yeah.
And let's see, C would cause friction to increase, D would cause friction to increase. What about surface area? That is kind of a little like trickier.
I just thought if you decrease the surface area, then the friction would decrease too. But,
So
but
so okay. Um okay. So okay, the thing is that it sounds like that would be true, right?
yeah.
But since okay, so let's say that instead of this object I had something that's much smaller. It's going to have a smaller normal force because it's a smaller weight, right?
Yeah.
So essentially, and since friction is just a function of the normal force, which is just its weight essentially, which is just dependent on its mass and gravity, the surface area actually isn't going to affect it.
Okay.
Now, if they asked you about air resistance, that's a little different. Okay?
Okay.
But yeah, this is a little tricky, so I would write that in. I'm going to write it in your notebook, just for friction. I'm just going to write SA, surface area does not matter.
Okay. Yeah. Okay.
But let's
Makes
say you
sense.
didn't know that. It would make sense that if it did matter, that more surface area would cause more friction, and this says decreasing it. So, following that line of reasoning,
Yeah.
yeah. So you have the right line of reasoning here. It's just one is just dealing with the material, and the other is what all friction is based on, which is the normal force.
Mm-hmm. Yeah. Makes sense.
Mm-hmm.
Okay. Okay, let's see. There's one passage. Oh, okay, we can do this one. Hold on. Yeah, we can do this one after. Okay.
Yep.
The kinetic friction. Okay, so I
Mm-hmm.
eliminated C and D for sure.
Okay. Well, you said C and D.
No. I chose B, but
Which ones did you eliminate? You said
C and D.
C and D. Okay. Increases. Okay. Just okay. So you knew that it was decrease. Okay.
Yeah, but I'm not sure what.
You're not sure.
Like between A and B, like how do I choose?
Oh, okay. Just because we're dealing with friction, which is always a function of normal force, right?
Is it?
Yeah, always. So I'll write that in here.
what's the equation? Like, how are they related?
I'll write it in this notebook. Wait.
Is it the force of friction is equal to the coefficient of friction times the normal force? Is that right?
Yeah.
Okay.
All
right.
Are you because there's a delay with the OneNote. Are you able to see like what
Are you keep on writing it on the same page as before?
Yeah.
Okay, no, I don't. I just see whatever's what you wrote before.
Okay. All right.
Yeah.
Yes. So let's see. Normal force. I guess they use capital N, so I just wrote whatever. Capital N. And then here I'll use red to emphasize the equations. Because there's the thing that people forget is that for static frictional force, it's less than or equal to.
Mm-hmm.
Okay. Yeah.
Right.
Oh, okay. I thought you were saying something. And then I'll write. So then, I wrote in the OneNote. Here, I'll just. Oh, I can hit that sync button. So the normal force is always perpendicular to the surface because it's a reaction to the gravitational force, which is always perpendicular as well.
Okay. Yeah, that's good. That's a good reminder.
Yes. If you can like think if you can like bring everything back to like those fundamental forces and see how all these other so-called forces like contact forces and stuff are just applications of that, you'll be good.
Okay.
So
All right.
yeah. So but yeah, so it'll be the one that's perpendicular.
Okay. Sounds good. And then we can go over like the next passage. This
Okay.
this one I think is like a super classic
What? Torque?
question. Yeah, force
Oh, like
that I
for
have
torque?
no idea. That I have no idea what to do. I pretty much guessed every question in this passage. So
Okay, so this is torque. That's what so that T thing is Greek for tau. It stands for
yeah,
torque.
yeah.
And so like torque is kind of like the opposite of work
Mm-hmm.
in the sense that okay, I'll just write work is, FD cosine theta. In other words, F and D are parallel, right? Because cosine of 90 is 0, right?
Yeah.
So okay, and then torque, which is represented with tau, is FD sine of theta, which in other words is F with a displacement perpendicular.
Mm-hmm.
Okay?
Yeah.
So we're dealing with torque. Now, okay, so let me see the question here. So, okay, so suppose the subject is holding a 4 kilogram ball, okay? During experiment 1, ignoring friction, what's the force exerted by the bicep? Okay. All right, and then we have distances. So okay, I'll draw like a little schematic here. So let's see. So okay, we have distance, bicep attachment. Okay, that distance from elbow, bicep attachment, lower arm center of gravity, hand center of gravity, tip of hand. So all of those are going to be on the same thing. And so, I'm just looking at what you just did right now. So, okay. This is like just a version of like kind of like those, like, have you seen those questions where it's like some plank or whatever, and there's a weight here and weight there or something? It's just like that, basically.
Okay. Okay.
Yeah. Or like a seesaw, like or like, you know, that kind of thing.
Yeah.
Okay.
I see.
So okay, I'll write down number whatever this number is, 15 or something. Okay. So we basically have so I'll just draw like a line here, and then the bicep thing here, and I'll just write like tau b for the bicep, and then the thing that's going down is that the ball, so I'll write something for ball. I guess they wrote A, I guess, or something. Alright, they didn't. Oh, M? Alright, whatever. So I'll just write tau M, fine. Like, but I would start there. I would start with, you know, those things. Right?
And I guess I just didn't. So they did mention that the weight of the lower arm was like 45 newtons, and I didn't know how that fit into the picture. Like I knew, I guess, I just didn't know why they needed to account for something that's also in the middle.
Uh-huh. Oh, it's because the bicep, when you like curl it, right? When you make it like whatever, go from like here to here. Or wait, it says experiment 1 kept it stationary. Upper arm was perpendicular to the ground, lower arm was parallel. Okay, so he's carrying it. They're just saying like, okay, like the weight, okay, like the weight that the muscles are going through.
Mm-hmm.
So let's say that ball wasn't there, right? Like that bicep is still responsible for keeping the rest of, you know, the forearm, right? In that position.
Right. Oh, okay. Yeah.
So yeah, so yeah, that's why they give you okay, distance. That's why they give you like, you know, the distance from elbow, kind of thing. So yeah, lower arm center of gravity. That's the distance for that. They give you the weight of the lower arm, right? Tip of the hand is the distance, you know, from the elbow, and then you multiply that by, you know, the 4 kilogram ball.
Yeah.
And yeah, and then you essentially just add up all of the torques. Yeah, so like, how are you with like the like math, like the centimeter stuff?
Fine.
Okay.
Yeah, like I think I mostly rely on unit conversions and like that to help guide me through
Yeah.
attempting towards the right answers.
Got it.
Yeah. But
Um. Okay. So, you know, so you do see it as, you know, those fulcrum type problems, right?
Initially not.
Oh, okay.
I
Yeah. Yeah. Anytime you're dealing with torque, think of that, because torque is essentially, or think about like a doorknob.
Right.
Like that's like torque. Or it's a rotation.
Right. It's just like if I just based on the question alone because it doesn't mention torque, so I didn't like make
I mean, like, yeah. So, yeah, it's still going to be, uh, so torque would have been a thing if the dude like actually like moved his arm. So I guess technically, like, torque. I mean, torque is happening, but yeah, okay. You don't have to think of it as torque because they are asking about force. You know what? So okay, first of all, you know what torque is, right?
Is it work? Kind of.
So it's closer to work than it is to force, because there's the displacement aspect of it, but it's just that work is always like a force applied that moves in a direction that's perpendicular to it, and torque is the same thing except for work is a thing that moves parallel to it. Torque is a thing that moves perpendicular to it.
Right, because it's torque is sine of theta.
Yeah. Which maximizes at 90, right?
Yeah.
So so basically, like, that's why they're using like tau, and like, yes, you are using torque here, because there's just because of the fact that, like, if you scroll down a bit, so just because of the fact that there's a force going upwards from that's the bicep, and then at that position, right, and a force going downward where the hand is and that ball, right, and force going downwards at that middle point of the arm. So, like, if the person was like, didn't have enough like strength to keep that straight, how would that move? It would rotate, right?
Yeah.
So
Totally.
so that's how. So yeah, think of it. So yes, even though they're asking for force, you're dealing with torque. It's just that they give you the displacement for the bicep, so we can find that torque and then divide it by that displacement to find that force.
That makes sense.
Yeah,
Okay.
and just one last thing. You see how it's 700 newtons?
Yeah.
That's a lot, right?
Yes.
Like, we just had a problem where some dude, like, suspended by his arms, like, lower half of the body weighs 700 newtons, right? So how can how can it be so strong? And that's the purpose of torque. Torque's purpose is like, have you ever heard, like, Archimedes said, if you have a lever long enough, yeah, you can, yeah, exactly, that's how.
Right. Totally.
So
I cannot believe I've seen similar questions like from other. I just cannot believe I didn't make the connection that this is like a lever situation.
oh yeah, just because I guess it's asking about force. From what I see in the passage, it doesn't really mention stuff about torque, but I would just ask myself, like, you know, how can this, like, if you just, like, let it go, right? Like if that person just let his arm, like his bicep, stop working or something, how would it fall? And it would, like, you know, like rotate in a rotational manner.
Right. So I just have a kind of related question.
Sure.
So let's say if I want to maximize my bicep strength,
Yeah.
does that mean if I have a longer forearm, it will be more it will be more efficient, or like it would generate more force?
Well, if you have a longer forearm, you're going to need a stronger. Well, it also depends on the weight of the forearm, but let's say whatever without the weight, right? Um. Okay, wait. Okay, so wait. Ask me that again.
So if I wanna, so comparing strength of bicep, let's just say a person with a longer forearm versus a person with a shorter forearm. Which one will have, which person will generate more force in their bicep?
Okay, so the person with the longer um, forearm, let's say that the weights are the same.
Yeah.
Okay, so the person with a longer forearm would require a stronger torque produced by that bicep.
Okay. Okay.
That's if the weights are the same.
Right.
Now,
Okay.
now, what about this? If the person has a longer, like this region, like not forearm, like upper arm, right? If
Yeah.
that was longer, then the person wouldn't need uh, a bicep as strong. If that makes sense.
Right. Okay. Yeah, it makes sense.
Okay.
All right. Next question.
Mm-hmm.
Oh, yeah. Yeah. It's just these type of questions I'm
Uh
clueless.
huh. Okay. Let's see. During experiment 2, did I leave my water here? Okay. So during experiment 2, the subject lifts a ball. So okay, we're finally doing some work here, right? Um, because movement, right? With a mass m, a vertical distance d1, and then lowers the ball a greater vertical distance d2. What is the net work done by gravity on the ball? Okay, so these ones are easier than they look because of conservation of energy. So basically all that's being done, right, is this ball, its gravitational potential energy is changing,
Right.
right?
Yeah.
And it's even asking what's the network done by gravity on the ball, right?
Right.
So we know that we're going to deal with MGH,
Yes.
right?
Correct.
So, all right, 16, okay. So I use like capital U for potential energy. Gravitational potential energy is MGH, and you know, that's if it's just one height, but the height in this case is just you know, from D1 to D2, right? So like, let's say this is like D1, and then okay, so lifts a ball, okay, and then lowers it a greater vertical distance D2, so D2, so it goes down there, so that's H, and so this would just become MG. Oh crap! Okay, I see. Because they're asking the net work done by gravity. I was just calculating the potential energy. So, well, actually, they're the same thing. They're the same thing in this case.
Yeah. No,
Uh,
I get it.
yeah. So, the thing that you chose, the conservative force. So
Yeah.
that's like if we did some. So, um,
I think it's. I thought, yeah, I think it'll be zero if it was moved lower to the same distance. Right.
Um, so here, wait. I'm gonna put this in green. And I'm gonna hit sync now. Then sync here. Okay, so you should see it in the notebook.
Yeah, I do.
So okay, the thing that I wrote in green is what's meant by conservative force. It means that it's independent of the path.
Correct.
So if it takes the blue route or the green route, it's going to be the same. That's the path, whatever. That's the conservative force aspect of it. Yes.
Okay.
But but yes, it doesn't. It just means that the work is the same. It doesn't mean that it's zero.
Right.
So yeah. But I wrote down the difference between D1 and D2, and I equated that to H for MGH,
Yeah.
which would just be MGD1 minus D2, right? Or D2 minus D1. It depends whatever you want for the sign kind of thing. So does that make sense?
Yeah, makes sense.
Okay.
All right.
I'm gonna get water. I'll be right back.
Yeah.
Okay. Okay. All right, maximum pressure in newtons per square meter generated by skeletal muscle.
I did the math wrong.
Uh-huh.
I did the math wrong. I know what I got wrong.
So let me see like how you do the math.
Okay. So this question is a unit question. So as I've highlighted here, one dyne is equal to this unit. This unit basically is like Newton,
Yeah.
except Newton is like kilogram times meter over second squared. So then if you look at the answer, it's Newton per meter squared, and then we have centimeters squared. So if you just divide this by that, and then work out the correct units, you'll get the answer.
Well, yeah. So I would write down basically, so okay, area is 1 cubic centimeter, which I would just equate to 1 neg 2 centimeters, but in parentheses squared. So I use like the shorthand E, capital E, which I highly recommend. Makes things go a lot faster. And that turns into 1 negative 4 cubic meters. So that's the area, and then the force is 7 E6 whatever dynes.
Yeah.
and then I would multiply that with 1 dyne on the bottom, and then on the top 1 e negative 3 kilograms times, well, I guess I'll do it step by step. So whatever. 1e. I mean, like, well, how would you prefer to do it?
Well, I just to be sure, I like to just convert everything back to so like grams into kilograms, centimeter into meters, and then convert this into meters.
So like when you do that, like how do you do that? So like for instance, like if I wrote down 1 centimeter, I would just write 1 e negative 2 meters.
Yeah, exactly.
Okay. And then for 1 gram, I would just write 1 e neg 3 kilograms.
Yeah.
So so 1 e neg 3 kilograms. All right, let me erase this part of the parentheses, and then times centimeters per second squared. So times 1 e neg 2 meters. Oh, and then I guess whatever per second squared. Okay. And then I would just divide force over area. So this should give you neg 5. Minus 3 minus 2. Sorry. Okay. 1 din is equal to 1 gram per, or rather 1 gram times centimeter per second squared. 1 1 over 1 e5 times, oh sorry, okay, that's the din thing, so that's that times that, so 7e 11 over that. Did you end up getting, oh okay, yeah, okay, that makes sense. Like, okay, so I guess, so I guess like I was just like writing out like how I would do it. If you see what I wrote.
No, I think there's like a lag.
Yeah, okay.
Maybe I need to refresh it. No, I mean it'll come up, I think. But yeah, no, I worked it out and like got the same answer. I just forgot to convert the centimeter the first one. So.
Got it. Yeah. Okay, cool.
Okay. Mechanical. Okay, yeah. Mechanical advantage. No idea.
Okay, so mechanical advantage is just a term that you use to see how well like a machine works. Like a simple machine, so that can include like an inclined plane, um, a lever,
Mm-hmm.
pulley, stuff like that, right?
Mm-hmm.
So essentially like um okay, so I'll write some stuff down. So essentially it works by so let's say it's like an inclined plane, right?
Yeah.
Um it takes more like by since work is like force times like displacement, right? If we want to reduce the force that we need to input, we do that by increasing the distance.
Mm-hmm.
Um,
Yeah.
the,
I mean, I
yeah.
guess my problem with this question is I understand the formula for mechanical advantage because I memorized it. So it's force of output over force of input, right? But then I just didn't know, I was stuck because I didn't know how to get those sources, therefore I gave up on this question.
Okay. Okay. Ignoring the weight of the arm, so we're not using that thing in the middle of the seesaw thing.
Mm-hmm.
What's the mechanical advantage of the biceps when lifting a ball in experiment 2? Um, oh yeah, what's going on in experiment 2?
It's just
Oh,
lifting
just
it.
keeping it stationary while lifting. Wait, oh, while lifting and lowering balls. So it's actually okay. So it's actually doing something. Okay. So mechanical advantage. So we're basically just going to be um, looking at how we can get a larger output by like a larger output force by making like essentially the you know the distance um uh
Yep.
by making like the whatever input distance like larger or lower or something like that. So let's see. Ignoring the weight of the arm, the mechanical advantage of the biceps. I'm just gonna write mechanical advantage, whatever. Force output, distance output is equal to four. Because the overall work doesn't change. Is equal to in force input times distance input.
Oh.
Yeah.
Okay, I see. Because okay, I see. So because work is the same, then you can relate these by distance. Is that why?
Oh yeah, yeah. Um, like yeah, I guess there's a delay in what I wrote, but if you look at that equation that they give you, if you cross multiply, you get force output times distance output is equal to force input distance input, right?
Oh
So
yeah,
yeah,
yes.
so work doesn't change. All you're doing is creating, a circumstance where the force um, that you input would result in something that has a larger output.
Mm-hmm.
That's if if it's a mechanical advantage that's actually going to work. Um, but it seems like it's not something that is very advantageous, right? So okay, all right, we'll do the actual like math here. So the weight of the ball. So okay, I'm gonna draw that same thing. Was 4 kilograms, right? So 40 newtons times whatever that distance is, and then the other one was the force of the bicep, times whatever 3 centimeters. So I'll just write 3 - 2 meters. Um, yeah. Can you see like the
No, it's not loading. Did you sync on your side? Does it auto sync for
Oh, no,
you?
no, just on the passage, just the distances.
Oh,
Oh yeah, there we go. Yeah. Okay. So okay, 3 centimeters, and then tip of hand 45. Okay. Okay.
yeah, this is not very efficient.
Well, I mean,
Or-
like, in terms of like the whatever the stuff that I write, I could just do like a multiple shared screen. So
Okay.
you know, I can I could do that. I could use like whiteboard and stuff. So there's a lot of things we can do with that. So okay, here I'll just do that. Because yeah, Microsoft Whiteboard works a lot faster, so I could use that for our lessons, and I can like copy and paste it onto the
Okay.
onto the notebook afterwards.
Okay.
So here I'll open up Microsoft Whiteboard. All right, here we go. Oh yeah, here. Let me share the screen. One sec. You can
So-
see my screen?
No.
Oh, that's weird. Okay.
So if the mechanical advantage is less than one, does that have an interpretation? Like,
Yeah,
or
it means that it's not really an advantage.
so because
yeah.
if it's greater than one, then it's probably better, right?
Yes.
Okay.
So yeah. So basically, like on one end, we basically have whatever we have a 45. I'm sorry, 40 newtons times 45, or rather 0.45 um, meters.
Yeah.
And then on the other side, we have some force, right?
Mhm.
Which I think we found in some previous problem or something, and then we have the 3 centimeters. All right.
Okay. Yeah, I see how this question works now.
Oh, okay. Tell me how.
Just as this equation says. If so if you cross multiply, then force of output is equal to force of input. So then, since force of output over force of input is the mechanical advantage, then distance of the input over distance of the output is the mechanical advantage as well.
Okay. So, okay. So I think, so do you think that the numbers you put in were reversed?
Yeah,
Okay.
because I was just thinking, like, how can it be? How can it be
Yeah.
that bad?
Okay.
But
Okay.
anyway.
Okay.
Yeah.
All right.
Okay. Okay, well, last question. Yeah. I was like 20 years later. It makes sense.
Oh, okay. Let's see this question you said. Okay, assuming the weight of the arm remains the same, how would the friction at the elbow change if the subject were to repeat the experiment 20 years later? Okay, so I'm sure it says something in the passage about how over time, like, the cartilage breaks down, right?
I'm not
Movement
sure if I read it.
What's that? Yeah.
I'm not sure if
It
that's.
says as
Oh,
people age, cartilage degeneration decreases lubrication between the bones, which increases the coefficients of static and kinetic friction, right?
yeah.
So if it increases the coefficients, right?
Mm-hmm.
The friction would increase, right?
Right.
Okay. So now we just have to see if it's going to be static or
Oh.
yeah.
It's static because experiment one, you're not moving. Right.
Yeah.
Because you're just holding the ball there.
Mm-hmm.
Okay. All right. Makes sense.
Yeah. That previous problem, um, could that problem be asked for experiment one?
Which one?
The one that we worked on before?
This one?
Mm-hmm.
For problem one? Experiment one?
Yeah.
Ooh. No. Yes.
Tell me.
Yes, I would say yes because, well, for it to have a mechanical advantage, you will have a force output and a force input. And since you said that even if you hold the ball there, you have to exert some sort of force, then there is an output element.
But what about the other part?
Yeah.
Because mechanical advantage deals with not just force, but what?
Work.
Yes.
Oh, if it's not moving, then there's no distance.
Then yeah, there's no work being done for experiment one.
Oh.
So this you couldn't this question, like, you couldn't answer if it was experiment one because there's no work being done.
Right.
Yeah. It's a weird thing. I remember in high school learning about it, like, technically speaking, like, from a physics perspective, like, holding something, you're not doing any work. It's only if you move it.
Right. Because you're not pushing it for a certain distance or whatever.
Yeah. But also it would have to be, like, as close to parallel as possible. So, like, let me put so is the Earth doing any work on the moon?
Yes. Wait, work?
Mm-hmm.
No.
Why?
Because it doesn't affect the distance. It's not like, I don't know.
I mean, like, if it's orbiting the Earth, its distance is moving, but there's another part there.
I mean, does it have to do with the force? I mean, there's gravitational force.
Uh-huh. Think about, what else is involved in work.
Oh, angle.
Yes.
Oh, okay.
Because it's perpendicular, right?
Right.
So, yeah, so no work is being done.
Because it's perpendicular. Okay. Right.
Yep.
Okay. Makes sense.
Mm-hmm.
Okay. That's cool. All right. What else can I ask? Well, I guess I could ask you about, so how well did you do on this chem and physics section? Did you get perfect on the section?
Yeah.
How did you do that?
Well, I mean, it was always my strongest like part. Like I majored in physics and biochem.
Yeah.
So there's that.
Okay. Okay.
But yes. How did I do it? I guess. This section is pretty much. I think of it as mostly discrete questions.
I agree.
Yeah. So I would look at the questions first, and go back to the passage if necessary.
Right. I feel like I read the passage the least in detail for this section.
Yeah. Because you don't need to unless you have to. Because, I mean, it's true for the other sections as well, except for cars. Unless you're really, like, in a hurry. Because it's good to see the passages, like, question by question. Or problem by problem, and there's only 5, 6 problems that you need to answer. So, a lot of scary looking graphs and stuff for the BB section, they're likely not going to even ask you anything about that. So, there's a lot. Yeah, so there's a lot that can be done that way. So. And yes, also the blueprint ones are really good practice because they're going to be tougher.
Mm-hmm.
So so those are really good. Let's see what else.
For the blueprint, did you do so? For the blueprint, initially I only did up to 1-6, exam 1-6, because that's and then I switched to AMC. That was my strategy.
Yeah.
And then because I was gonna retake it, and I did try to take an older exam, but I realized I was actually I remembered the passage, so it wasn't didn't feel right.
You're gonna have retroactive interference or something. Proactive interference. One of the two.
So it's proactive. Your old memory interfering with your new memory.
Correct, yeah. So you're going to get, something that's going to be all weird. So you don't want to, really retake tests unless, sufficient time has passed and it's completely brand new. But things are still going to, interfere. So you want to get as much of, a pure attempt as possible. So, so I would, so you took the AAMC stuff, and what about the section banks and things like that?
Yeah, so I did those, and I'm thinking of doing those kind of 2 weeks out. So I'll start next week. Because I want to kind of do them every day. So then, if I start now, then I will run out of questions.
That's if you run out of questions, that's just a good that means that then you can move on to some of the blueprint work.
Yeah, I do blueprint. I did blueprint this morning. I did a section of cars.
Oh, so I would say for blueprint, the cars is useless.
Actually useless?
Actually useless, yeah. I would advise for blueprint, just do the other sections. And for cars, just do the AAMC stuff.
Why is blueprint bad?
Blueprint's perfect for the other sections, just not cars. Basically, nothing is good for cars except AAMC. And fortunately, AAMC gives you sufficient material because you have the 4 AAMC tests, right?
Yeah.
So that's 240 questions, and then you have question pack 1 and 2, which is another 240, right?
Yeah,
so that's around 500.
I've done the question banks. I've done the cars one twice over at least. So the problem is
all of the really.
Yeah, I did them twice over. So the thing is, I do realize that when I read something the second time over, I do understand it better.
Well, yeah.
But then it doesn't work on the exam because
because
like
it's the first time.
Yeah, so that's the problem. But like it's weird because I also question the blueprint cars, but I feel like my cars is so bad that I can't even tell the difference. They're all just bad.
Yeah. So like the way that we went over the cars passages, I think would be the best bet. Like let's say like like we would do it like let's say like we like choose one and go about it together, and I would like kind of like ask you like questions that aren't the questions that are asked already, but that would make you look at the passage in another way. Kind of like how like today I asked you like what about this question in experiment 1, and that's just a way for us to do some work on work, right?
Yeah.
So that's something that we can do, because like it's like again like it's not about getting like as much material done as possible, because if you're not like I always favored the approach of like less material, more understanding.
Okay.
So like with like the passage that we like went over yesterday, like it went very slow, and I asked you the questions, and like you made sure that you were able to know exactly why this answer is right and exactly why this answer is wrong.
Right.
That can still be done, even though you've done all the things before. Like like we can do it together, and I can like supplement it with asking you like I'll ask you like questions like what's like what's this person saying, what's what's to highlight, like what's the thing to highlight, like what would the author think about this.
Yeah. I mean, so like for cars, were your score pretty consistent? Like it didn't improve much, pretty much, or is it like did you improve on it?
No, I improved on it. I basically like just started doing like the question bank, and at a certain point it clicked. I understood like what kind of thing they were asking for.
Right.
So all right, like quickly, like let me show you. So I can go to an email that you sent me for a passage.
Mm-hmm.
Let's wait. Where is it? Okay. So you said like I remember you said something about. Okay, I see your car's scores fluctuating.
Yeah. Like I think so. I took the MCAT 2 years ago as well. So that was my first time, and I did not study for that at all. Which was a bad idea. And I got 125.
Yeah.
Which is still bad, but I was like, okay, if I can improve on all the other sections, then just like my cars just stay like that, fine, like it's fine for like where I want to go to. But it's just this time it was like really bad. So and like even when I was practicing, I was getting like 127, and I thought it was weird. I was like, what? Like I did not believe that like my car's skill would just like improve on its own. So like it was kind of weird.
Yeah. No, so okay, I'm just trying to look for that the email you sent me with the card stuff. Or if you want, you can show me you could show me some random cars passage. And
like
yeah, just anything.
Right now?
Yeah.
Okay.
I'll go over like yeah.
Okay. Hold on.
Mm-hmm.
I need to open it. Okay, so cars. Which one would you like to?
Anything.
Alright, let's go to. Well, I just reset them. So it's not very accurate. Let's go to, okay, I haven't reset this one. Okay, let's go to this one. This is bad. Okay. So let's go to, let's do this one.
Okay. So, all right, we're gonna go through this together, but faster than yesterday. All right, and we're just going to go like paragraph by paragraph, right? So, first of all, it's saying I'm gonna like paraphrase. So okay, first basically it's kind of saying well. Okay, so sometimes people have to do a skill or a difficult task in front of an audience, right? So they usually want like people that like them, right? A supportive audience, right? Um, then it says, okay, we don't know if that's going to actually help or not, right? So then it says we're going to do an experiment. Okay?
Yeah.
So that's what I get from the first paragraph. Second paragraph, experiment 1, right? They used a friend, right? Oh, wait. Sorry. They used a friend and a stranger. Okay. And they basically found that... Okay, they actually found that the friend makes them perform worse.
Yeah.
Okay. Then... Okay, it seems like like the reason for it is slower rate of responding, but I see that as kind of like if they ask you to elaborate on it later.
Which one?
So the first thing I take away is just that having a supportive audience makes them perform worse, and then it tells you why. So on my first read through, kind of like that passage that we had yesterday, where I was like, all right, we get it. We're not going to read the rest, but they're probably going to ask us like supporting evidence and stuff. So that's where I like, it's like the slower rate of responding. Like that's the how, right? Okay. So, etc. And then some people said that they were not aware, and then they're distracted, and it's okay. The negative effect, they're trying to figure out why is the supportive audience going to produce a negative effect. They're saying it's apparently not due to the discomfort of being judged. Okay. The researcher concluded that so, okay, and this is just the reason why a supportive audience impairs the performance. The conclusion that the researcher reached, which is that it makes them go slower without being more accurate.
Yeah.
However, that's just saying the how, but not the why. So they're saying the reason for this is unclear. Then it talks about how it's hard to figure it out. Okay, then let's see, experiment 2, right? All of them were strangers, right? So this is like, a double blind or no, single blind kind of control kind of situation. And then they said that the supportiveness was manipulated. So if the stranger, they said that for the strangers that had to pretend to be supportive, they had an incentive, a financial incentive, right? Participant. Sorry. So, okay, sorry. They gave the participant in the supportive audience condition that they'd get a cash prize if they worked, if they did the difficult skill thing fast. I'm sorry, not fast, like better. The neutral one was told that they were the only ones to receive the prize. So this is just basically to create like controls, right? To make sure that a neutral or a stranger like can act sufficiently as a support audience and sufficiently as a neutral audience. Okay, then experiment 2 confirmed the prediction that a skilled performance would suffer with a supportive audience. So basically, we have proven that in both of these experiments by using both an actual supportive audience and one that faked it. Okay. Other questions remain. These are just like, things that like we can look at essentially if they ask for it. Okay, so suppose that a psychologist is interested in the performance of trial lawyers. On the basis of experiment 1, the psychologist should predict that a legal argument will be more effectively presented. So, okay, experiment 1 was saying that a supportive audience would hamper your effectiveness, right?
Yes.
Okay. So, let's see. So, trial lawyer. So, I'm going to say, is it B?
Yeah.
Yeah, because experiment 1 is all about supportive audience makes you worse. So, based on experiment 1, if you don't know the judge, or rather, if the lawyer or whatever is friends with the judge, supportive audience, he's going to perform poorly. So this was just like an example. Like yesterday we did it slow. This time we did it really fast. But in the process of going through it really fast, like I just looked at experiment 1, experiment 2, basic conclusions, and answering the question, and then if another question asks you something else, we'll look for it.
Okay.
So yeah. Okay, so alright, what's the explanation for the slower rate of performance? So this is exactly what I was saying. Like this is where, so like the first run through you focus on the actual results. Second run through, they're gonna ask for it is like the why or the how, right?
Yeah, I understand that, but also this passage is it's not like a typical cars, right? Because I think typical cars is more abstract and like more of like a flow of thought instead of like 1 versus 2.
I mean, like it's more similar to like a PS section, but it's AAMC, so you should be ready for any type of whatever passage, because there's a lot. Like this is like more of a like it tells you at the end, like it's basically from the American Psychological Association, so it's like an experiment. So, but you should be prepared for any type of passage, because they're like usually like, and also going through your results, you can see which types of passages you have more trouble with. You could see which type of questions you have more trouble with as well.
I can see the passage, but I still haven't figured out the type of question.
You could see that, you could see that in the in the ones that you get wrong, like in the page, like where you see your score or whatever.
Like, are you talking about like the skills, like reading between the text?
I believe so. Yeah, like I think so, right?
There's like 3 different skills. There's like reading.
Oh yeah, there we
this
go.
one?
So yeah, this tells you. So okay, yeah, it tells you like the questions that you get wrong and the passages that are typically going to be tough for you.
Yeah, like this part, yeah, mostly it's humanities in it, and like philosophy or like literature,
Mm-hmm.
things like that. But in terms of like the skill, usually it's an even spread, so I don't.
Well, like, okay, so foundations of comprehension is just, the most important one because that's like you understand the main idea, essentially. Reasoning beyond the text is like the what is the author implying, right? So you have to make like an inference.
Mm-hmm.
And then reasoning within the text is just the grunt work, what's explicitly stated, like what is most supportive or supported. Um, yeah, and then as for, all these sections, uh, that is going to be like your best tool, I believe, because you know which ones to like focus on. So if you want, like I can like put them into like an Excel spreadsheet and see like which types you like from basically like the 4 tests that you took and then the 2 whatever question banks, right? Because we have a lot of data here, so we can just see like which your problem areas are, if that makes sense.
I mean, the question bank I reset, so I don't think it has the one like the result from before
Oh, okay.
because I reset it.
Okay.
So
Um, so the way that we just went over that passage, like what did you think about that?
like the method or
Like in terms of like you've done them all before, but was it helpful or is it helpful? Like I went through it fast this time.
Yeah.
But is it helpful for us to go through it like together like that?
Yeah, I think it's helpful. I think going through it slow, like yesterday, was more helpful, probably.
Oh yeah, definitely. Yeah, I went through it fast this time just for time's sake.
Yeah.
Um. So yeah, of course, yeah, of course, it's more helpful that way. Um. But I guess what I was saying was since you've done every single thing that's cars,
Mm-hmm.
like what to do now, right? What to do now is we can do like passages together, and like that one I just went through it fast to show you like what is possible.
Mm-hmm.
But normally like I would go through it slower and I would just ask you questions and ask you like what to highlight, what to pay attention to, what is like the important stuff and what's not the important stuff.
Yeah, no, it's definitely good. I like to be asked questions.
Yeah. So yeah, basically, what did you want to do? Like 2 hours today?
Yeah.
Okay, so we got I think we have time for like another one. So let's do like another random one, and we can do like a hybrid of the 2 methods that we did before.
Oh, wait. When did we start today? We started. Has it already been 2 hours?
No.
No?
No.
It hasn't been 2 hours? Wait, it's 5 o'clock already. Didn't we start 2 hours ago?
Almost.
Oh, okay. Okay.
Mhm.
We can do. Oh my god. Okay, let's just keep going. So this test,
Yeah.
I messed up in the middle section. You'll see. This is where the problem was. Don't know what happened. We can go through it. Okay. We can start with. Oh yeah, it's a literature. It's a literary thing that I don't understand. Okay.
Is there so I guess it's annoying that they don't let you like without resetting it. You know what I mean? Like getting rid of like the highlights and stuff.
No, I don't think so.
Yeah. So, okay, I'm gonna let you take the lead here. So, tell me what's going on.
All right, I need to read it.
Oh, this is a perfect example of, remember the classics I was talking about?
Yeah, exactly. Yeah, definitely. That's what I struggle with the most, for sure.
Wait, what?
Just like this type of writing, like anything that has to do with literature.
So tell me again what the classics are.
Greek and Latin.
All right, good. Okay.
Yeah.
All right.
Okay. Writings. Basically, that writing is just a form of message, and the consensus is recent.
Mm-hmm. So so writing is just to reconstruct something that's said vocally.
Yeah.
Okay.
And then it goes on to the history of, because it says it's not recent, so it's going to talk about the past.
What part is recent or isn't recent?
The consensus too. The consensus that writing is a reconstructed vocal message.
Mm-hmm.
Is recent among linguists.
Mm-hmm.
Okay, 5,000 years ago, writing.
So okay.
Right.
Here, what's a phoneme?
A sign based on sound.
Okay. Like telephone,
I mean, I didn't know what it was, but I guess it's like a type of writing.
Mm-hmm. Yeah. But like based on sound, like have you ever heard of like hooked on phonics?
Is it wait sign sound?
Yeah, the phonics part is referring to sound.
Like buzz, things like that.
Wait, like what? Oh,
Like
you're thinking of maybe onomatopoeia?
No. Yeah, maybe.
Oh yeah, no. So so just like that prefix indicates sound.
Okay.
So yeah.
Okay.
Like phonetic, yeah. Okay.
Okay.
And then morphemes are syllables or categories.
Okay. And then, so there's two types of signs. And then later on, right. So then writing is the key to societal evolution. So this is where the disagreement is. The Greeks do not think that some think that writing is not worthy.
Mm-hmm.
Right. So Plato thought it was worthy.
So Plato thought that
writing is worthy.
Well, so wait, read that part again.
Plato.
Yeah,
before that. Myers certainly did.
Yeah, but before that.
Some question writing's worth.
Mm.
Oh shit. Wait. Some question the worth. Oh yeah. Then he questioned it.
Yeah.
Yeah. So he
basically
questioned it.
Yeah, he basically said that if people just read stuff, they can misread it, they can misunderstand it, and it is better to debate things because it makes your mind more active.
Mm-hmm. Yes. And then later on.
So the spoken word was superior. Plato.
Yes.
I would like highlight Plato, spoken word superior, because he's not a fan of the writing part.
Yeah.
Okay.
I can't highlight.
I know.
Okay. And then later on, this person went to Egypt.
And again, any words that you don't know, let me know.
Okay.
All right, so now I see another thing here. So like we saw phoneme, morpheme. Now I see ideographic. So that's a new word. So I know you can't highlight now, but I would highlight or say like something like ideographic means that you're expressing metaphysical thoughts directly in script without letters, words, or sentences.
What are metaphysical thoughts?
So have you ever heard of like meta?
Yeah, meta is yeah. It's used a lot, like metadata or something.
Okay, tell me about metadata.
Metadata, I think it's just like data. Well, it's like to keep track of the data.
So it's data about the data.
Yeah, exactly.
So metaphysics is the physics of physics.
Oh my god.
So in other words, like essentially like a philosophical interpretation of physical things.
Okay.
Okay.
All right. All right, and then.
So you can also think of it as just ideas.
Okay.
And you see how it says without letters, words, or sentences? And this is what he says like the Egyptian language was, which is like, hieroglyphs. Anyway.
Sorry, I'm just reading. Information has been divided by the Greeks about age. Became inclusive. Does that mean it's like not accurate? Like the information transmitted by the Greeks about the Egyptian is like basically like not right, not what it is.
Yeah. That's why there's other words like allegedly ideographic.
Okay. So then next we have another person. Right, so this person was credible at the time, and then also said that Egyptian script were ideographic, and also Chinese and Mayan were also ideographic.
All right, but what happened before that?
Before this, that he translated and then spelled out the title of this, whatever that is, as instruction on securing.
So he messed up, right?
Pardon?
So he messed up, right?
I got the sense that he messed up only from this sentence, but I didn't really understand.
So that sentence says that his reputation gave credibility to the ideographic thing, but since he messed up,
wait, where did he mess up?
Oh, just so it says that this dude translated an inscription which actually spelled out the titles of a certain pharaoh he mistranslated it as instructions on securing divine protection from the god Osiris instead.
Okay.
So him messing up, right? So before that, they say that the Egyptian script, right, was allegedly ideographic, right?
Yeah.
And then they say that this dude Kircher or whatever, he popularized the view that it was ideographic.
Right.
He messed up, but people didn't know that because he had a really good reputation. And then some other dudes like missionaries and explorers said, hey, guess what? Mayan scripts and Chinese scripts are ideographic as well.
Right.
But you see how there's a little, like, that might not be true because they're basing it all on someone's reputation who was wrong.
Mm-hmm. Yes.
So
absolutely.
you might see, just to expect what might come.
Right.
So this is saying, so the Mayan and Chinese thing, they're saying that this is independent proof, right? That non-alphabetic scripts used metaphysical ideas, aka ideographic, not phonemes, which were sound-based, or morphemes, which are based on like sentence structure and stuff like that. So okay, so this ideographic interpretation of language is growing at this point.
Yeah.
But we know that it's based on some dude that was wrong.
Exactly.
So,
because eventually they will both recognize and that.
Yeah. So I want you to be able to, like as you read this actively, like to be able to like foresee that coming.
Yes, I do foresee it, but it's because I read it.
Yeah. But you see how we could have from the stuff from before, right?
Yeah.
Good.
So, eventually this was proven that's not true, although some textbooks still says it's ideographic.
Mm-hmm. Mm-hmm. Yeah.
So,
yep.
Now it's going to explain why that is.
It's going to attempt to.
Right.
Because of the word perhaps. So they could say perhaps some of this persistence in believing that ancient Egyptian, Chinese, and Mayan writing is ideographic can be explained by basically colonizing society about could be so okay, maybe this is because colonizing societies view colonized societies as being like whatever, like ideographic.
Yeah, because it's not as like advanced.
Yeah, because they associated, right? Because Greek and stuff were like based on phonemes and stuff, so they associated that with like civilization, like being civilized. So they're saying like, so they're making a connection to this like colonialist thing. All right, and then they're saying okay. So they're saying that they think, or the colonialist view is that writing started with pictures, then ideographs, then phonemes.
Exactly. So then theirs is more superior.
Yeah, so those who were civilized wrote phonetically. Okay, so now they're asking what evidence does the author use to support the contention that Renaissance scholars misunderstood Egyptian writing. So we kind of foresaw this, but it's also useful to go back and make sure.
Right. So sometimes what I like to do is, after I read a question, I like to come up with an answer myself. I don't know if it's good.
Yeah, no, that's good.
Okay, so what evidence does the author use? I think right. So then that was that paragraph talking about how this person
Effed up.
did it. So I would think it's not D because he did not correctly understand it because
Right.
he
Mm-hmm.
translated wrong. So this is not really true.
Mm-hmm.
It doesn't. It's not relevant. It doesn't answer the question. So it's B. Yeah. Okay.
Yeah. So
Review.
as we work together, like you're going to be able to like foresee these types of things, like, like actively, like at the same time as you write it. At the same time as you read it.
Mm-hmm.
Like when I was looking at that, I saw the dude messed up, and everything after was based on him. So everything after got messed up because he messed up.
Right. Yeah. I mean, first time around, I knew he did something bad, but I was like, okay, whatever. Because I don't know. Because I feel like sometimes reviews throw you off by like doing some examples and like. Anyway.
Yeah,
Okay.
yeah. I mean, it's yeah.
Okay. Under the assertion.
Okay, so if you didn't know a word, you should ask me. You didn't ask me, so what does onslaught mean?
Like under the dwindle under the class. Like domination.
Yeah, like
Kind of.
slaughtered, like right?
Yeah. It like got rid of it, kind of.
Okay,
Not really.
so which of these things, that are not in the passage, but if you included it in the passage, would support that?
So A is not true. Or A doesn't like support it, the statement. B is not true. Okay, C is not bad. D is irrelevant. So I think it's C.
Yep. Because we're looking for something that, if true, means that Egyptian culture goes down.
Right.
The classical world, remember I told you that's going to come up?
That's right.
Yeah.
Because at the time I did not know what classical world is.
Yep.
Okay, wait. Classical world. So that includes. So whenever they talk about classical in the capital C, they're saying like Greek or like Roman in this case.
Yeah, it's like essentially like the the foundations of Western civilization.
Right. Okay, let me. Yeah, because I had no idea at the time what that meant.
Mm-hmm.
Okay, cool. So you would say that knowing what classical means is like very essential, right?
Not essential, because you don't necessarily have to know exactly what the passage, like the you don't have to have knowledge to answer, to do well on it, but I guess it can help because it can help make things faster.
Yeah.
So like, I mean, like for me, like since I've been like tutoring like critical reading since I was like 15, I've ended up like reading like thousands of these kind of things. So you kind of pick things up, so it can give you an advantage. But if you want to focus on getting better at cars, like there's a lot better things you can do. But like it certainly does help. Like it does. Like I like yeah. Let's see. Supported the view that it was ideographic.
According which following situation? Well, I think 2 is definitely right.
Okay.
So then, wait, why did I cross it up? So then I will cross up this one, but that doesn't really help.
Yep.
So, okay, this is where I'm gonna get confused. So, missionaries report. So, because in the passage it said that it was independent, right? So then that means it has nothing to do with. It has nothing to do with the Egyptian script, right?
Well, they're asking what would support the view that Egyptian script is ideographic?
Yeah.
Okay. Now, if they found that the Chinese and Mayan scripts were also ideographic,
Mm-hmm.
it would support it.
Yeah,
because
that's what I mean.
Because it's independent, but if you didn't know that, just look at Roman numeral 1. Like, that is literally what he didn't do. Like, he didn't say that pharaoh, his inscription listed his titles.
Wait. Okay, hold on. Yeah, like number 1, I did not understand. So hold on.
Mm-hmm.
Claim that. What is listed in his titles? Like, this is very confusing.
Well, I can tell you, but also, like, here it just says he translated one inscription which actually spelled out the titles of that dude. So he didn't do that. So, but if you do want to know, titles would be like, he, is the son of the sun god Ra. He's, the descendant of, like, this other god. Inheritor of the universe. Things like that.
Okay. Yeah, I didn't know what that means.
Yeah, you don't have to. That's just the supplemental stuff that I can tell you if you wanted to know. But you do see that it says that he did not get that right. Like, the thing that the inscription listed the titles,
right.
But he thought it was like some instructions on how to get him over to the afterlife with Osiris. So Roman numeral 1 is out because he did not claim that.
Right.
So that means that you cross out A, B, and D.
Mm-hmm.
So it should be C.
Yeah, it is.
Okay.
Yeah, I was very thrown off by this entire phrase because I did not understand what that means.
Yeah. But do you see how you don't have to? So, like, think of it as, like, he translated something. So it says he translated one inscription that was actually about this pharaoh's titles, right? As something that is not his titles.
Yeah.
So then Roman numeral 1 is not true, and you have the answer right there. Because there's only one choice that does not have Roman numeral 1. I think I said Roman numeral 2. I meant 1. Because that is not true, right?
Yeah.
And only choice C. Choice C is the only one that doesn't have Roman numeral 2. I mean, choice C is the only one that doesn't have Roman numeral 1.
Okay. Yeah, that makes sense. Because I think my logic, I went the other way because I didn't know what this means. I just skipped it, so I looked at 3 and I'm like, so since they said that it was independent, so it was not related, so I crossed out all the ones that I agree. So that was wrong, obviously.
Mm-hmm. Yeah.
Yeah.
But like, it's like if I'm saying that, whatever, Blueprint is a good thing to use, and someone else that I don't know says it too, right? That's independent of what I say, so it should support that statement that Blueprint is good, right? Because it means that we're not like like colluding with each other or conspiring, right?
Okay.
Mm-hmm.
Yeah. Oh, that's it. Oh, that was only 4 questions.
Yeah,
Okay.
so, worst case scenario, just take it, one question at a time. Right? Because every passage is going to be like 4, 5, 6 questions, so, don't, let it get to you. It's just, 4 or 5 questions, and, your time could be better spent elsewhere.
Yeah.
But yeah, we can, go over, like, more of this next time. But like that type of like method, was that helpful for you?
Yeah, for sure. I think that's probably the best way to review cars for me.
Yep.
Yeah. I also felt like, so between the last time, well, the first time I took the MCAT versus the last time, it was probably like a 2-year gap, and I knew that, well, reading is my weak point because I just haven't read a lot in my life. And so I tried to read, and actually I think it helped me improve a lot. But I just felt like as more practice, the more questions that I do, the more confused I get, or like the more unsure I get. So it's like kind of bad.
Yeah. Like it's after a certain point, it's like you did well the first time, which is good baseline, and then you started to adopt a habit of reading, which started to make your comprehension and speed like improve as well. But I think like maybe around the time where you just kind of like tried to force it with like doing like maybe passages again and then having like that kind of thing, it kind of worked against you. So, think about like the work that we do together as like a fresh take on everything.
Yeah.
So, when we saw that passage, see it as completely something new. And like I'll like help guide you and, ask you questions and things like that. Because like, you're starting to see like, things that you kind of like glossed over at first, but seeing like the importance and connection of that, and it's going to help you predict things as well.
Yeah, for sure.
Okay.
Yeah, that's helpful. I think what I'm gonna do is just try to do more physics questions that are similar to what we went over today to see if I could apply it.
Yeah, see if you can do like a blueprint CP section.
Yeah, I'm gonna do it tomorrow.
Okay. Because I've had like students that tried to go too specific with physics type of questions, and they're like rarely going to come up. So try some of the blueprint ones, and whatever you're trying, if it's UWorld or Blueprint, you can send it to me in the email. I can try to explain it in the notebook. Okay.
Yeah. And that makes sense. Yeah, because I think for physics I'm fairly comfortable with all the other topics except force. That's,
so just think about those two forces.
Like if anything else come up, like I know I can somehow pull a formula on some question or like figure out the units somehow. But force is just like a little weird. I don't know.
Yeah, just remember that there's only really going to be 2 types of forces. If you can break it, if you can like reduce it to that, you will be fine, because don't think like with the tension and ropes and pulleys and things like that, there's only it's just gravity.
Yeah, sounds good.
All right.
And then I think I was talking about like genetics and like cell biology stuff.
Yeah.
It's mostly, I think it's just like interpreting graphs that I've never seen before. I think that's intimidating and sometimes it throws me off.
Yeah. Only look at those if you need to.
Yeah, exactly.
Because a lot of the times they don't even ask you a question on it.
Yeah.
And they're meant to, like, the entire test is meant to psych you out. Because pre-meds are very, thorough and want to know every single part of it. And, a passage like that is going to be, like, dense and full of, like, acronyms and, like, Krebs, minus, wild type, several different, like, on one graph, several different lines and, just so many things that you want. It's information overload, and you want to be able to chunk it into smaller pieces. So, it's like a way to see more with focusing on less, if that makes sense.
Yeah. No, I for sure, like when I look at figures, I just skip them. And then if they ask about it, I'll go back to it.
Good.
That's kind of like
Good.
But sometimes I get thrown off by it because I think something that's different from the EMC practice test and the actual test, I think the actual test has more like bio and biochem passages that deal with like pathways of things. Like it will at least like for mine, there was like a lot of questions on like, oh, this thing activates this, but this thing deactivates this, and then it just goes on like 5 times.
I could show you like the type of shorthand that I use, that I also teach my students, which helps like decipher a really long, dense passage into really easy things. Because I kind of just draw like I guess like I'll show you like when we come to it, but like I would like write down like what the thing is, and I draw an arrow to what it does, and then if it inhibits it, I'll like draw like a cross. Like if you can develop like some type of like schematic like shorthand to decipher that, because you can't do it verbally because there's too many like double negatives. Like,
Exactly.
So I'll show you like how to do that. Okay.
Yeah, sounds good. Okay.
All right.
So are you available this week? Like later this week?
Mm-hmm.
Okay. Yeah, I'm basically free every day. I'm just studying every day. I'm not doing anything.
Okay.
Okay.
So okay, here. So you send me more stuff, and I'll get back to you, and then we can do like my student for tomorrow. Like I probably will see this student. So, but like I think like maybe Thursday or Friday could work.
Yeah. Or Sunday or Saturday.
Okay. Yeah. We can do
fine.
that. All right.
Yeah.
Anything else?
Yeah. No, that's it. Just studying.
Okay. Yeah, you'll be fine.
Okay.
All right, take care.
Yeah.
All right, bye.